Hi, so today we are going to discuss system design on design a news feed, basically discussing on how to design Twitter, Insta, Facebook, and any other news feed. Right? You can pick anything, and we'll start facing on the basic functionality, and we'll focus mainly on these requirements. So let's start discussing the functional requirement and non-functional requirement. So basic part, right? What we can think of as a functional requirement for Twitter, Insta, or Facebook. Mainly, if there's a user and they can publish their feeds, that is first. That will be a first requirement. Second will be how a user will view a feed. So let's say someone will post it, and how his friends or followers will view their feeds or scroll feed, whatever. Same. Then a third part will be in the same requirement is number of followers. How do we manage followers and following? That is third thing. Fourth is a kind of add-on requirement, right? How do we handle close friends? Let's say if Instagram, right, we had that functionality where you can select a post that you want to show for a specific group of friends, right? Not open for all. So how do we handle that thing? That comes under privacy and security. So that is one thing that we're going to discuss. Fifth is, let's say if some celebrity or some verified user posted something like Ronaldo, maybe Donald Trump, or let's say Messi, they posted something. How do we manage that? Next, maybe how do we manage notifications? And then we'll discuss, this is not the requirement, but maybe we'll discuss it separately. Okay, so these are all the non-functional, these are the functional requirement. On non-functional requirement, foremost priority is it should be to read fast, because we are designing Insta, we are designing Twitter. uh, Post should be visible at very fast speed, and it should be highly scalable also. Whatever we are designing, it should be scalable. Two things. Now let's start our discussion. So starting at very basic, right? What do we need? Obviously, you will start first at follower and following. Let's say a user comes in. Let's say some user comes in and they started following some. They started following someone, right? I'll make it simpler. Uh, let's say there's a user. Let's say there's a user X. There's a user X which started following. There's a user A which has started following X, right? So now in our user follower DB, if A follows X, if let's say A follows X, so X is followed by A. That means user is X and follower is A. So this is how we are going to store in our user follower DB. Similarly, we need to also store it in user following DB. So user following DB will look something like this. So let's say we have one more table over here, which will be user and following. Following. That will be A follows X, and similarly B also follows X, and similarly C also follows X. So these are two databases basically. One is user follower, another one is user following. Simple. Now the problem. Let's say we have this two database. Fine. How do we store when let's say A follows X, right? Let's say our first query will store something on user follower saying A follows X, X is a user, A is a follower. We'll store, fine. Next we need to store some same thing on user following also. So A is a user, following is X, A follows X. But the problem is here it will be really slow. Why it will be slow? Because we need two-phase locking. It should be committed in both the databases. Unless and until if it is not committed in both the DBs, our transaction is going to be failed, or we need to revert whole operation, because if this problem occurs, that we will get, okay, in A's account it will be visible as A is following X, but in X account it is not visible that X is followed by A. So our transaction should be committed to both the DBs. So this is a two-phase locking problem, and obviously if you're committing to two DBs, obviously it will be slow. How do we solve it? Here's our solution, where will we use CDC approach, which is change data capture. So what is this approach? Let's discuss in detail. So CDC. So what we will do? Change data capture. So what we'll do here? So let's say some user maybe A comes and follows X in user follower DB. We are going to store X as user and A as follower. Fine. We'll talk about this DB later, which DB we are using and why we are using. That is, we'll discuss in detail later. But for now, let's say this detail is being stored in DB. Now this data is being read, and if there's any insert so there are three kind of operation that can be performed, and our CDC will capture it. Mainly insert, update, and delete. So if any of these three operation will happen, our change data capture will catch it, and that will be processed through our Kafka producer. We'll apply a Kafka as a messaging queue over here. If any change get data capture occur, so our Kafka will produce the event, and that event will be consumed to a Flink streaming services. We are using streaming services over here, which is Flink. Why we are using Flink? We'll discuss that also in detail. So if some changes happen, our CDC will capture that change. Kafka produce that event. That event will be consumed by our Flink consumer, and that same Flink consumer will consume it and process it and further broadcast, not broadcast, I will say, basically propagate it, or insert that change, or update our user following DB, right? So here's the whole flow. Let's say some user comes in and follows some user. So at first instance, we will store that data into our user follower DB. In user follower DB, if any changes comes in, either any query like insert, update, and delete, our CDC will catch it. Once CDC catches it, our Kafka will produce that event. That event will be consumed by our Flink services. That Flink service will again push that data into our user following DB. This is our whole process that we are going to be doing. Yeah. So other thing, like another assumption, like why we are using Flink over here. So what Flink does for us? So these are three main purposes of using Flink. One, it does checkpointing. Second, data couldn't be lost in a streaming pipeline. That's why we are using streaming pipeline. We should be very sure that whatever we are storing in user follower, that should be stored in user following also. So data shouldn't be lost. That's why we are using Flink, because it has checkpointing. How does checkpointing? We'll discuss that also. Third, it has state managed. It actually manages the state also. How it manages the state, we'll also talk about it. So there are two types of storage it has. One is state managed, other is checkpointing based. So we'll discuss about both, but first we'll see checkpointing, how it manages checkpointing. Okay, so let's say Kafka produces event and Flink stores it, right? And it has some details, which let's say X is followed by A and B, and similarly it will replicate that event to your following DB. Assume Flink failed at some point. Let's say it has data till this point where it says X is followed by A and B, but when this event comes saying X is followed by C, our Flink restarted or failed, or it's not up due to any kind of issues. So what it will do, it will pull the checkpoint from S3 or SDFS, anything, right? Any services, whatever we can use based on our requirement. It will pull the last state or last checkpoint. From that it will know that, okay, I have the data till this state, so next I need to get the data after this state, basically the B state, right? So it will ask Kafka, it will use Kafka to replay messages from that state only. This is how Flink will do the checkpointing. Okay, next thing, we have the Flink to store the user data, basically user following data. User follower we are directly storing. Our next problem, how do we publish a feed and then show it also? So let's say this is the end approach that we are going to discuss. Let's approach the direct approach, the brute force solution. What could be done, right? What we want user that whenever someone opens their feed, their friend's feed should be easily accessible. It should be very, because whatever we are designing, it is read heavy. One more thing that we haven't discussed is, right, based on CAP theorem. Let's discuss that also. So as per CAP theorem, so what we need over here, obviously there are three things basically: consistency, availability, and partial tolerance. So what we need and what we don't need, obviously we should have partial tolerance, so we cannot trade off partial tolerance. That should be there. We need to trade off something in consistency and availability. So what should we trade off? Do we require consistency? We do not. Even if something shown to me in after few minutes, it's fine, it's not any issues, but it should be not that consistent, but it should be available. Our service should be up. There's no point that Instagram or Twitter should be down. So service should be available. It should not be consistent, fine, right? So what we are trading off? We are trading off consistency in place of availability. So our application has availability and partial tolerance. So let's talk about this thing. Now, how do we publish a post? So let's say some user X posted something like 1, 2, 3, right? And we will not discuss this thing. Let's say we'll discuss it later, the privacy part. User X posted something on, let's say 1, 2, 3, right, or some post. We directly stored it in our post DB. From there on, again, I'm going to use the streaming service, and I'm going to use same CDC thing, change data capture, because that is very reliable over here. And what approach we are going to use? We are going to use fan out on write. The problem, why we are going to do this, right? Let's say again, what is the brute force approach? Brute force approach is, okay, we will just X, there's a user, they directly post something on their DB, then when someone comes, let's say X posted something, and A, B, C comes in and they want to view the feed of X, right? They have to pull the data. So it's a read heavy application. Okay, it's a read heavy application, and what we are trying to do is we are doing most of the operation during the read time, which is wrong. So somehow we have to do most of the operation in write time only instead of read time. So what we are doing is do everything on write time only instead of read time. Time, yeah. So what's the approach over here? We are going to use fan out on write. How this will work? Okay, let's again restart. So let's say some user X posted something like 1, 2, 3 on post DB. We directly stored it on post DB 1, 2, 3, right? Again, obviously we are storing post ID in post DB. We are not storing actual post. Actual post will be in some CDN, some other S3 location or CDN service, based on where how you are storing it, right? But post DB will only store the post ID, or if there's an image, it may have image URL or something. But let's talk about that later. So post DB will have post ID. Then through CDC, a change data capture, Kafka will read it. Kafka will read the event, and will produce the event. It will produce the event to Flink. Again, we are going to use Flink as a consumer, Flink as a streaming services, right? There may be a question that what are other alternatives to Flink. So Spark job or Spark streaming services could be one alternative. I'm using Flink over here because I think Spark will be more beneficial in terms of if there's more data, or we are processing high end data, as in a volume of data basically, right? But Flink could be most optimal solution and best approach with Kafka, because both are designed by Apache, so it's very much compatible with Kafka, right? That's why we are using Kafka. Sorry, that's why we are using Flink. Now comes to this part, right? So Kafka produce something that will be again consumed by Flink. What it will do? That is one thing, that it will have this data, that X posted something. X posted, let's say 1, 2, 3. It will have this data. Similarly, there's one more pipeline, that X, sorry, that X followed by A. Obviously, we will have one more pipeline, or we have one more DB, that if you remember, we already talked about this. Whenever X is followed by someone, we are storing that on user follower DB, and we have already applied a change data capture over there, right? Now we are we'll create one more pipeline. So one more pipeline will go to this again through our this thing, Flink streaming services to user following DB. This is one more pipeline that we are creating. Do not confuse this with the above one. This is a different pipeline that we are creating. This one basically. So what we'll do? X followed by A. It will be captured in a user follower. Now again through CDC, it will produce one more event to Kafka, and Kafka will see it, and Kafka will produce one more event. This event will be that X is followed by A, right? And now Flink knows that X posted something, and X is followed by A, B, C, right? How it will know? Because that's what I mentioned earlier. It has a state managed DB also. So it uses ROG DB behind the scenes. Okay, so it uses ROG DB, and it also uses hash map internally, which is in memory. ROG DB is kind of a file storage. We are not going to not going to be detailed in there, but I'll tell you how this works. This state managed thing works, right? So okay, so coming back to this only. So when X is followed by A, it inserted something on DB, in user follower DB, then again produces the event through Kafka that will be consumed by Flink. Flink has two set of data, that X posted something, and X is followed by A, B, C, right? Now, so Flink has everything, so it knows who follows X and what X posted. So what it will do? It will put that post into newsfeed cache of A, B, C, user A, B, C, right? How this is beneficial? So just assume, right? Just assume what we are doing over here. When someone A opens their phone or Instagram or Twitter, right? They will directly see the latest coming news feed, right? It will be very, very, what I'll say, it will be very fast. Very read optimized kind of thing, right? So, and it's very worst case scenario that ABC have different cache. So cache is basically designed geographically based on their location, interest, and multiple other things, right? That is distributed based on some parameter that could be anything like let's say geography, interest, right? Or maybe friend circle, right? And mutual friends, or interest, or whatever, right? So it could be decided based on this only. So it could be one cache, it could be multiple cache, right? But at worst, it could be whatever X follows, those many caches will have that post, right? So this is how Flink's going to work. Now the question arises, right? This is a very, very costly solution that we are designing. I'll say no. How much costly? How much costly it could be, right? Then application that has very read heavy, right? Now if we do not design it like this, obviously we are doing most of the operation on read when user is going to read something or see something, right? Then we are going to do most of the operation, which is obviously not ideal. That's why it should be not that costly, giving the idea that most of the companies like Twitter, Instagram, they have this kind of money to have these many caches for multiple users, as in multiple users in a different geographical locations. So it should be a very reliable operation. We can go into details of how much memory it will take. We can have a set of let's say back of the envelope calculation also, but we are not going to that details. That is not very much important right now. Okay, so quick thing over here, right? So what we did till now, we have obviously user follower DB, and we are also saving into user following DB also. Now we did post also, we saved into the user newsfeed cache also. Now questions. This works very well for normal user. Okay, fine out on right approach. But will this work with verified users or celebrity? No, it will not work. So let's say Ronaldo comes in, right? He posted something. He will have 500 million followers, 600 million follower, right? So obviously if we are going to push that into multiple caches of whoever follows Ronaldo, it will be a very hectic operation, right? So what we'll do, we will reverse the approach, or we'll use hybrid approach. Let's talk about that. So let's say Ronaldo comes in, he posted something. Again, through CDC, Kafka will produce the event. It will be consumed by Flink. Same thing. Now there'll be one more pipeline. So when a user comes in or registered, they will have a user DB, and user DB will have the information that okay, that user is verified user or not a verified user. So once a user turn into a verified user, through same Kafka pipeline or Flink pipeline will produce one more event saying okay, this is the user which is a verified user. So now Flink knows that Ronaldo posted something and he's a verified user. Okay, so what Flink does, if a user is a verified user and he posted something, instead of putting that data into newsfeed cache, he'll put it in the popular feed cache. That popular feed cache is specific to the celebrity people only, not for the normal people, right? So anyone who has verified tick, their feed data will be stored into the popular feed cache. Now again, this how this will be designed. This is based on the requirement, number of followers, and many other logics, right? Again, geography will come into picture, interest will come into picture, the data set comes into picture, multiple things, right? But this is how it will look like. Now this is one thing. Let's say Ronaldo posted something, it will be in popular feed cache, fine. But let's say me, Neeraj, right? Now how I will see that data? It is again one question. Because when I come to the Instagram or something, I want to view the post from Ronaldo, right? But the problem is I need to query the database to get whom I follow, right? So basically when I comes into to Instagram, so every time I need to query the database to get me the list of celebrity users whom Neeraj follows. Right? And then it will hit the popular feed cache of Ronaldo. Will this be the best solution? I'll say no. Why? Because again, if we are doing some if we are doing some read operation while doing the read, right? I mean, it's reading from cache is literally fine, but when we are hitting DB, it will cost us. It is slow. Multiple things. Our application will obviously went down. So what should we do? Okay, so one more approach that we can follow over here, which is, so let's say Ronaldo posted something, right? And we have this thing. We are already storing into the popular feed cache, right? Now what we can do is, so whenever Neeraj followed Ronaldo, right? So we have user following DB also, right? Obviously, if you remember, we have this user following DB, right? What we can do is we can have one more pipeline. Again, I'm going to use CDC and connect this to the same Flink pipeline. So we have user following DB. What we can do is we can use change data capture again. Again, Kafka will produce the event that okay, Neeraj started following someone who is a celebrity user, right? Obviously we'll know it, right? Or whenever Neeraj started following someone, that again goes through the pipeline, that whenever I started following some celebrity user, it will go through the pipeline and it will store over here in Flink. Now Flink knows that Ronaldo is a verified user and I followed Ronaldo, Neeraj followed Ronaldo, right? And whenever Ronaldo posted something, right? So it has the data. How Flink work internally, let's say, right? So it has a list of verified user, which is Ronaldo and Messi. Whenever someone followed celebrity user, that also pushed through Kafka to Flink. So it has that list also, that Ronaldo is followed by Neeraj and these many peoples, right? So is following Ronaldo a verified user, then it will push. It will push. So basically what will happen, whenever Neeraj followed someone or someone followed someone, it will go through this pipeline. If that user is a verified user, it will check if that user is a verified user. So what will do, it will join that. Basically there's a joining needed, but I know, I mean, it looks like a costly operation, right? But how many verified users will be there? Not many, right? So whenever a verified user comes in, that data went through went through Kafka to Flink, right? So what Flink will do, whatever I'm following, Neeraj follows Ronaldo, it will do something like this, that it will make a list that Ronaldo is followed by Neeraj, John, and many other people, right? Something like this. So it will make a list. So it will join the user following data to the verified user data, right? That is one operation Flink will do for us, right? It will basically joining all the data, whatever is streaming through the Kafka to Flink, it will joining the data and putting into Flink into the state managed DB, and then obviously checkpointing it later to S3 also, so that it will never be lost. So how it helped us? It helped us in a way that whenever Ronaldo posted something, it already knows that okay, this Ronaldo person, this Ronaldo verified user is followed by Neeraj and John. So what it will do? It will put that data into user celebrity cache. So there'll be one more cache, which is user celebrity cache, again partitioned on user. We'll talk about partition later, how I'm partitioning all these things, right? So whenever Ronaldo puts in, I'll put this data into user celebrity cache. So this cache again will be partitioned on user ID. It will have the details that okay, this user, that let's say Neeraj follows Ronaldo and Messi. So user celebrity cache will have this detail that this user follows these many verified users. Simple. So how we solve the problem? Now let's say I came in. I want to see first anything. I want to see the post from my friends. I want to see the post from celebrity users or anyone who I follow, right? So first thing, my friend's post will be loaded from the newsfeed cache. Simple. Here only. Next, if I want to see some post from users from some celebrity, so what I'll do, I'll hit the cache, user celebrity cache. It will give me the list of celebrity whom I follow. Let's say I follow Ronaldo. Once it get that list whom I follow, I will be redirected to popular feed cache, which has all the details of what Ronaldo posted, what Messi posted, or anyone posted, right? So this is how it will be very fast, very read fast kind of application, right? So that is our goal, if you remember, read fast, right? So this is how we designed it. Talking about one more thing, I guess we covered most of the things. Notification, we can maybe when someone, let's say, push something, whenever we are posting something into newsfeed cache of A, B, C, we can notify the user also based on whoever user in this newsfeed, for whomever user this newsfeed cache is designed, we can maybe push out a notification to those users, right? So this will be a notification service. Similarly on popular feed cache, not popular feed cache, maybe user celebrity cache also. Whenever the data comes into the popular feed cache, we will have one more pipeline, right? So now, quick question. I guess we'll have one more thing to discuss, which is close friend. How we'll design close friend thing. So let's say if X posted something that is only for close friends, how we'll design it. Okay, let's say this thing is only for close friends, not accessible for all, right? How we will do it? Remember, we have user DB, right? In user DB, this is how I'm going to store name, ID, verified, close friends list. So our user has all these details. What is the name of user, ID, is the user verified, the close friend list. This is all I'm going to store in the user DB. So obviously, and if you remember, I'm already streaming everything into Kafka and to Flink also, right? Whenever a change comes in, right? So my Flink knows for a particular user who are the close friends. So whenever, so this is same Flink consumer. So whenever X posted something, and it is only for close friends, he applied a check that okay, it is only for close friends. It went through Kafka to Flink, right? Now Flink knows that if this post is for close friends, so what is the close friend list? That close friend list will be flown through this stream, through this pipeline to Flink, same Flink pipeline, right? Now it has the list that okay, in close friend X is followed by A, B, C, but in close friend X has only, let's say, A and B, not C, right? It has that list, right? So what it will do, it will push the newsfeed, it will push the data to newsfeed of only A and B, not to C, based on the check. Just one more if condition, right? So yeah, I guess we pretty much covered everything: publisher feed, view feed, follower following, close friends, how to handle servability, notification, highly scalable, read fast. One more thing that I want to cover is partitioning. So everything we are partitioning on user ID. Okay, before that, why we use Cassandra? We use Cassandra because of its, whenever we need a high write throughput, we can use Cassandra, right? And there's one more thing. If I want to get the list of followers, right? Let's say who X follows, right? So it is kind of a wide column store DB. It will store something like this: X is followed by A, B, C, D. So just a single row return, right? Single row return. It will be very fast. That is one thing. And it has leaderless replication. That is again an opportunity, right, to use Cassandra. And it's a heavy write throughput. Whenever there's a heavy write throughput, we can directly use Cassandra. This is very, very easy to use, right? I mean, very, very reliable in these kind of scenarios. And we don't need to use RDMS in this case, because obviously there's no relational kind of thing, right? So that's why we went with Cassandra. Second thing, partitioning. Obviously, Flink, whatever the Flink consumer, right? Everything we are going to partition based on user ID. Why? Because obviously when I need to get the list of followers, right, it should be really fast. Basically, one Flink partition will have all the details, right? So it will not be like that. It will not be the case that one Flink partition will have X followed by A, B, and then other Flink partition will have X followed by C. It could not be the case, right? That is not good. So one Flink partition will have all the details for particular user. I'm not saying that only one Flink partition will have one user details only. I'm saying one Flink partition will have one user details will be stored in one Flink partition only. I mean, it could be more than one users, but one user could go into the one Flink partition only, completely. Similar to this also, Cassandra DB also, it will also be also be partitioned based on user ID, because whenever we are querying something, that all the user details will be in one instance of DB only, right? It should be partitioned based on user ID. Same on this also. Everything, even the newsfeed cache, it should be partitioned based on user ID, right? I guess we pretty much covered everything. So that's it for now.